Hello, today we're going to look at the point-slope form of a line. There are many forms of a line. Point-slope form is the form that we're going to look at today. Alright, point-slope form of a line is this formula, y subtract y1 equals m times x minus x1, where m represents your slope and x1, y1 can be any point on the line. It's super useful whenever we're only given the slope and one point on the line. Parallel and perpendicular lines are an application that this comes up in a lot, as well as when we're looking at data and we know one data point and we happen to know the rate of change, but we don't necessarily know the starting point. That's why point-slope form has an advantage over slope-intercept. Slope-intercept form always has to have the starting point. For point-slope form, it can be any point. And of course, finally, we do recognize at the end, it will convert back to slope-intercept form or standard form. Let's take an example. Write the equation of a line with a slope of 1/2 through the point 2, -3. Well, first I'll start with my point-slope form since I've been given the slope and 1 point. My point-slope form of a line, y minus y1 equals m parentheses x minus x1. Remember, you need your slope and you need a single point. So I'm going to identify those up here. My slope is given to me as 1/2 and my point 2, -3. So the x coordinate is the 2 and the -3 represents the y coordinate. Since they're color coordinated, you can see where those plug in. And I've got y subtract -3 equals 1/2 parentheses x minus 2, but of course y minus -3 is really y plus 3, and that's point-slope form. Sometimes you're given the equation and just asked to identify the pieces of the point-slope form. So if I were given the line y subtract 5 equals 2/3 x plus 9, and I want to know the slope and at least 1 point on the line, then I'm just going to start looking at the equation. First, I recognize that this equation is in point-slope form. The y subtract y1 all lines up very nice. M x minus x1. Well, wait a second. Notice that this subtraction is not in this equation. It's an addition. I need it to be a subtraction. So how do I make that a subtraction? Well, of course, we know minus negative is equal to a subtraction. So now we can see that x1 is actually -9. So we are looking at a slope of 2/3 through the point -9, 5. Let's write the equation of a line given a graph. In this situation, I'm given 2 points on a graph, and I'm sure I've done these before with slope-intercept form. Of course, I'll need the slope, and I'll find that in a moment, and I'll need the intercept. But this particular one doesn't appear to fall on an integer. So there's my 1 and my 2. It's somewhere between 1 and 2. So I don't want to take a guess on it, so instead I'm going to use point-slope form. First, I find my slope, of course. As before, rise over run, I'm going down 2 units and over to the right 3. So my slope is -2/3. But which point should I use? Well, the answer is you can use either point. Either point will work. Let's go through each of them. Y subtract y1 equals m parentheses x minus x1. I recognize the 2 is my x and 0 is my y. So when I substitute those values in and simplify, I get y equals -2/3 parentheses x minus 2. Notice the minus 0 just kind of disappeared and I've got the y equals instead. Let's try the same thing with the point 5, -2. So I recognize that 5 represents the x, -2 represents the y. And of course, y minus -2 in the front turns into +2. So I have y plus 2 equals -2/3 x minus 5. Well, that looks kind of strange. Are these the same equation? Think about that for a moment. In order to find out if these two equations really are the same, we're going to have to change forms. So I'm going to change each of these back into slope-intercept form and compare them. So the equation on the left, of course, I'm going to distribute the negative 2/3, and I'll get negative 2/3 x plus 4/3. On the right, I'm going to start with distributive, negative 2/3 x plus 10/3. And then, of course, I'm going to have to subtract 2 from both sides. Now, I've got my fraction here, and negative 2 is the same as 6/3. So 10/3 minus 6/3 is, of course, 4/3. And yes, they are the same. So hopefully you can see there that it doesn't matter which point you choose. If you convert them back over to slope-intercept form or even standard form, you will end up with the same. Hope this was helpful introduction to your point-slope form.